Okay, our goal here is to learn how to find the inverse of functions that involve logarithms. This one is log base 5. And the first step to finding an inverse is to switch the x and y values. So you can see that I replace the x with a y and the y with an x. Then you solve for y. In this case, y 2 was subtracted from y, and then the logarithm was taken, and the final stage was times 3. So when you're solving, you've got to strip off that last layer first. To undo times 3, you divide by 3 on both sides. And that takes you to the logarithm by itself. At this point, the trick is to know how to unravel a logarithm. You start with a base, which is always the subscript number. You raise it to the power, or the exponent that's on the other side, and that will equal the expression that used to be inside the logarithm. So in this case, base 5 to the x over 3 is equal to y minus 2. Notice that when you do that step, what used to be small and low subscript is now a normal size font base, and what used to be normal size font is now a superscript, in other words an exponent. Now if you add 2 to both sides, and then just rewrite it with the y on the left, you have your inverse function. Whatever this original function does to numbers, this will undo. Let me give you a couple more examples of this. This is an example involving a common logarithm. A common logarithm is a logarithm where the base is implied or not written. In this case, there's a 10. It's always a 10 for a common logarithm. And once again, we're going to switch the x and y. And we're going to try and solve this for y. You'll start by getting rid of the multiplication that's the outside layer here. So I'll multiply this by 2/3 and this by 2/3. And we end up with, at this point, 2/3 x equals a logarithm of x of y plus 5. Now, what you need to know about a common logarithm is always base 10, and the 10 is not written, it's implied. So I'm just going to sneak a little 10 in there. Take 10 to the power, or the exponent that's on the other side, and that will equal the expression that's inside. So 10 to the 2/3 x power is equal to y plus 5. And if we subtract 5 from both sides, we get 10 to the 2/3 x minus 5 equals y. All that remains is for us to put the y on the left. And that is the function that will undo what the original function does to numbers. So that's the inverse function. One more example, and this time the example involves a natural log. You know it's a natural log because it's abbreviated ln. You know it's a natural log because it's abbreviated ln, and the base when it's a natural log is e. The number e is about 2.718, and it's a familiar base for anybody taking upper division mathematics. First, switch the x and y. And we'll solve for y. At this stage, you need to know that the base here is the number e, and e, if you're curious, is about 2.718, and it keeps going. You take e to this power is equal to that expression. There's only 2 steps left. We need to add 2 to both sides. And if we're trying to clear the 3 here, you're going to divide by 3 to undo that. And you get your final answer of y equals e to the x minus 5 power plus 2 all over 3. As you can see, sometimes these answers are fairly complex looking, but the point here is that if you plugged a number, let's say 7, into this function, you would probably get a really nasty decimal answer, which then, if you put in for this x value, would take you right back to the 7 that you plugged in to start with, and hence it's an inverse function.